All right. How's everybody doing? Hello, hello, hello. Welcome to the stream. Okay. Where are we at? I just got confused. Okay. Let's get moving. We're going to work on the MC-10 schematic a bit more tonight, as soon as I can remember where everything is at. That's not it. That's not it. Let me open up one file and then we'll get going. Hey SG, how you doing? Welcome to the stream. Bit preserve, where'd you go? Come back. I don't remember where I put the schematic. Okay, now I remember. Yeah, okay. All right, and then let's go this one. Okay, here we go. Oh, my windows are backward. I was like, why isn't anything working? I was looking at the YouTube preview, which is always way, way behind. Okay. All right, so where we were last time, we're working on the MC-10, which is a TRS-80 computer. It is a color computer. It is not the Coco one, which I believed for a very long time. I think we got like a chunk around the microcontroller, or the microprocessor. We got that done. So I think we're going to move on to some other areas. Can I resize that? Yas. Okay. And I believe where I was thinking we were is, okay, I'm going to put that here. And then we're, every time, every single time. I always forget. I wish there was like some way I could like save 2 sets of window positions in KiCad, because when I switch my display back to 1920 by 1080, it always wants to place it as if it's still at 4K. And that just does not work well. There we go. All right. So we were down here somewhere. I was thinking actually last time, I think I was going to start with the connector, but I want to wait until I'm like tired and burned out on this thing, because that's not too difficult. So I think my goal today is we'll get U8, U7, and whatever this junk is, and let's see how far we get by focusing on those. I also might spend a couple of minutes trying to colorize the buses, just because I was looking at the schematic I did for the Game Gear, and color coded buses are just so much nicer to look at. So, okay. So right off the bat, we need a 74 LS 174. I can make this a little bigger for you guys, which is totally for you and not at all for me. I can see it just fine. No questions asked. All right. So if we look for a 174, we have a 74 LS 174. But since we are recreating this schematic, let's see if its pinout matches. Oh, that's a 373. We need to go over a little bit. We need this one. And no, of course, its pinout does not match. Not even close. So what we're going to do is we're going to edit, and then I'm going to say edit library symbol. And then I'm going to go File, Save a Copy As. We'll leave the name. I'm going to add MC-10 to the end. And then we're going to add it to my library. What do we call the library? Uh-oh, I already forgot. Yeah, can I borrow yours? Well, actually, no joke. So I'm pretty, I think I'm due for my annual eye exam. So I got my new prescription in December of 2022, right? Because last year was 2023. And then by March or April, my vision changed, like just slightly. And the prescription has given me trouble most of the year. And so I think I've figured it out, but it was really irritating because I bought new glasses for the first time in 7 years, and when I wear the new prescription glasses, I can't see clear beyond where my monitor is, and that just drives me insane. So I'm still not sure what happened. Why? I mean, my vision, my prescription hadn't changed in almost 10 years. So, hey, Francois, welcome. I hope you had fun at FOSDEM last week. Looks like there was tons of cool stuff going on there, as I would expect. All right, so let's go ahead and move this stuff over. I'm going to turn off the well, I guess we can leave it on, because the properties never fill up. All right, now I'm going to move this over a little bit just so we have a little more room to work with, and then we're going to reorder. We're going to reorder everything. So I think we'll do the same kind of thing I did last week. So let's So the easy one is let's move the clock up because that is clearly going to move. Let me get these guys out of the way. Really wish there was a better way to handle those. All right, so we'll put the clock there, and then power and ground and clear is 11. Oh, that can't be right. Oh no, clear is pin 1. Okay, I'll move. You know what? We'll play along. We'll go ahead and move this one over. I just realized I'm editing the wrong one, aren't I? IR. Yeah. Okay. We need to do 74 LS 174 MC-10. Open up this one, and I'm going to hit save. I'm actually going to close this. Yeah, discard those changes because I was editing the wrong. Silly. Let's go back to symbol editor. I've got to get that workflow cleaner because I want to explain to people how to do it easily, and I always mess it up. So Neo's 6502, interesting. Is that? I don't know. I've seen a lot of 6502 stuff lately. I'm having a hard time keeping up with the things that people are working on, which is in no way a bad thing. I think it's awesome. That processor just will not retire. All right. Okay. And then we're going to move the clock. So I'll hit M to move all that stuff. We'll just move that. I'm going to highlight these and move them back. And then our outputs, I'm going to bring down just a little bit so that we get our schematic will look a little closer to what this guy or what the example one is doing. So let's save this, and then this one's going to be the easiest. So what I'm going to do is I kind of wish you could unpanel or undock. Yeah, so I wish I could do exactly that. Really? Oh wow! I didn't realize that was going to happen. I feel like that's new. Well, I mean, the properties panel is new, but being able to like move it to somewhere else or float it, I don't. Okay. I wanted that because I wanted to be able to come over here so that we could just do this real quick. So 12. So I'm going to do the pin numbers first. 7's the same. This looks like a 5. 4 is a, let's see, then this is going to be a 2. And then this one is going to be a 10. So we got 15, 12, 7, 5, 2. Okay. And then I will go ahead. I don't really feel the need to rename these the way that they did, but since that's what their schematic has, we'll go ahead and do it. And it's so freaking easy now. 1, 2, 3. Whoop, missed one. 4Q, 5Q, 6Q. Okay. All right. That was easy enough. Retro board with a 65.2 and a 2040 emulates everything, including the RAM. Nice. There was a Arduino based project like that a couple of years ago. It used a ATmega 2560, and it only used the 2560, the Mega board, because it wanted the extra RAM that was in the 2560. But it was the same idea as you could plug in a 6502 or a Z80, and then the microcontroller emulated the rest of the computer. And so, like for example, it emulated an Apple One. You just and then with the Z80, it might have been able to run CPM. I don't think so though, but it's just a similar idea. So I sort of like those ideas. That idea in terms of hardware emulation is use a real processor but emulate the stuff that goes around it. I mean, I'm actually not entirely opposed to, say, implement a processor in FPGA, even though Western Design Center doesn't give away their core for the 6502. But I know some people thought, because of my comments on the Mega 2 video where I wasn't using I didn't want to put the Mega 2, connect it to an FPGA because or build the Mega 2E around an FPGA, because that defeated the purpose of the project. But I mean, I don't know. There's a lot of stuff that'd be a lot easier on it if I did connect, say, a real processor to the Mega 2 and then an FPGA to do everything else. I mean, basically doing that with the two RP2040s, right? So, same idea. Yeah, now I think about it, it's basically the same idea. All right, we're going to call this one clear. All right. Cool. So let's save that, close this, and then we're going to delete this symbol because we just created the one that we really wanted. That was just a shortcut I was using. 74LS174 MC-10. There we go. Now, if I was creating this schematic from scratch, I would probably either just use the built-in symbol, or I would only edit the symbol within this schematic. Even though it's really not needed starting with version 7, I like having a external library with the components for each schematic in the BitPreserve archive. Part of the reason I did that, or I wanted it that way early on, is because KiCad didn't really handle libraries, or it didn't really handle shared library stuff very well. But now, starting with 7, maybe 6, but definitely in 7, symbols and footprints are copied into the project and linked back to the library, so that if the library is gone, you don't need it anymore. All right. Okay, I'm actually going to just copy this whole thing right here. Missed the ground. All right. So this is kind of a deep cut, but I noticed this the other day, or either the last stream or the stream before, in KiCad 8, I was like, I noticed when I move the symbol around, it was definitely on a thick grid. And then when I move text elements around, it's much, much finer. And I sort of just ignored it for the moment because I didn't really know what was going on. And now I have found it's actually a new way. It's a new feature. In preferences, there are now grid overrides for connected items, wires, and text, where regardless of what your grid is set to, these are the settings that will get used. And the reason they did this was because the N as in not a good idea, hotkey changes the grid. So see, as I hit it, oh, this is nice too. I didn't even know that it popped that up. That's cool. So as you change grid, well, you can change grid. And the problem people were running into is they would hit N and change to a grid that was not a multiple of 50 mils, and it would cause off-grid connection errors in the schematic editor. And so now, number one, I actually really like this. I really like the fact that this pops up, because now it's like, oh, I didn't mean to hit N. But number two is, even if you get on a weird grid, or maybe you say you set it to be really fine for text elements, whenever you move something or make wire connections, the grid is forced to 50 mils or whatever the overrides, whatever you make the override. And what I really like, and I really mean this, is this was a great example of how the issue on GitLab was to unmap the hotkey, which is what I recommend. Starting with version 6, I recommend it to everybody, is undo that hotkey, because it is going to cause problems for you at some point. And so that was what somebody put as an issue in GitLab. And the development team said, no, that doesn't make sense. We don't want to do it that way. And eventually they came up with this override system instead. And it's like, okay, well, now that I see it in action, I really like that they did that. And I think it's really cool how it's like, okay, well, yeah, they were opposed to doing the change as it was given to them, but they weren't opposed to making a change. And I think that's really awesome. So thanks for coming to my TED Talk. Okay. I wonder what is this bus right here, this black one? I don't know. But I just think this would make a lot more sense if I just did this. Now my grid is there we go. Not Q, Z. Yeah, Z. Why isn't that? What? Why won't it? What? Okay. What's going on? I can't. So I'm hitting Z and I can't click on. Does it? Wait a minute. Is it because I keep hitting Q? Oh. It doesn't like having them connected at the same point. Oh, I wonder if that's a problem though, because I feel like I've done this before. All right, got all that. Okay. Interesting. So this did not get all of the data bus. All right, fine. Fine. Be that way. Let me try a quick dear sir. Run. Basically, I wanted to know if it was going to give me any errors right here. It didn't, so we're just going to move on. Okay. Now clear is this pink line, and it connects to, is that reset? Yeah, it connects to what becomes reset. So what if we just said, oh, why did that get messed up again? I'm going to move this over here. We're going to highlight only what's inside the box. Delete that. Then move this back to there. Okay. So reset is connected to this chip's clock, which I really kind of think we're just going to do this. And then I'm tempted to make it like a color. But I'll worry about that later. Okay, so that is connected, I think. Wait, did I get the right one? That might be the wrong one. So it's this line, so it's the top line. Yeah. Whoops, that was not reset. Okay, I'm just going to do this then. I'm just going to draw this up to here until we get to this part of the circuit, because that connects to those NOR, or I was going to call them NOR gates. They're not NOR. What are those? those exclusive or? Oh, there's door gates. Really? Oh, it's been a long time since I thought about those. Okay, whatever. Moving on. All right. So these all go up here at some point. So I'm not going to bother drawing any of those. Oh, what's that clear connect to? Oh, clear connects to reset. Okay, that makes so much more sense. Dummy. What were you even thinking? Okay, ground connects to ground. Clear connects to reset. Which this drawing has it go under here and then up through here. Which may not have a very clear path for us. Yeah, I don't like that at all. Do not like that. Yeah, I think I'm just going to leave it as reset for the moment. Because otherwise, we have to move everything over to make that work. Which I guess we could. We really could. I could just grab all of this. And I don't know if G, I'm going to try G. I don't know if G's going to let, I don't know if it's going to let me drag this. Okay. That's actually a lot better than I thought it was going to be. Okay. Now I can take reset and come this way. I'm going to leave the bus labels for now, just because they're easier to tell what's going on then. Okay. So we've got that chip. I don't want to do these other signals yet until we get the other chip above it. So let's do, or I think this is like the video controller. I'm assuming, because it says V. But I don't want to, we'll draw these lines. Might even do those as a bus just to make that easier. Okay. Now we can do this 245, which I don't think we've created a new one of those yet. All right. So 245, roughly above this one. And it goes 2, 3, 4, 5, 7, 9. Oh, so close. All right. All right. We'll do the same thing. We'll edit this one and do a edit library symbol. Then we'll do a file save copy as MC-10, MC-10. All right, and then I'm going to come up here. I'm going to do 245 MC-10. Double click on this one. Hit save. Move this back over. And then we will modify it. So B0, 1, 2, 4, wait, so 18, 17, 15, there's, okay, 16 moves. 14 moves. And let's see, so, oh gosh, these are in my way again. All right, so we got 18, 17, 15, 13, 11, and 12. And then 14 and 16. All right, so that looks good. And then we should go ahead and change these names just so they match the schematic. Shouldn't be too hard to do that. I wonder if there's a trick. Can I right click? Nope. Okay. The trick is click on the pin and not inside the package. That's the trick. All right. Wait. Oh, yeah, these are way different. 1, 2, 3, 4, 5, 6, 7, and 8. That looks good. All right, VCC, direction. Okay, so ground, they moved over here. Not super excited about that, but okay. I'll do that because I see what they're doing. I'll put that there. And then the direction pin, we'll put, I was hoping we'd get that a little closer. And then let's go chip enable. All right, I'm going to move this even though it won't do, for some reason, doesn't seem to make a difference. Okay, can I move that over one? How do we do this? How can we make this better? Maybe I will just kind of off-center these a little bit. Not my favorite way to do that, but I think it makes more sense. All right, so this now goes 2, 3, 5, 7, 9, right? 2, 3, 5, 7, 9, 8, 6, and 4. Right? 2, 3, 5, 7, 9, 8, 6, 4. 18, 17, 15, 13, 11, 12, 14, 16, 10. Got it. That looks good to me. All right, so now we're going to go, these are all off by 1. No, that one was fine. I could have left it alone. But no, I had to go and touch it. 8, 6, 7. Nope. Supposed to type a different number there. And then 8. 2, 3, 5, 7, 9, 8, 6, 4. Cool. All right, so that one's in good shape. Let's go ahead and close this. We're going to, I'll just delete this. I was going to use change symbol, but there's no reason to do it that way. All right, so we'll put this roughly here, even though this clearly is going to move. Right, because that, oh, I see what they did. I see what they did. Okay. So really what I should have done, now I see this, we should have really moved this whole thing over. So can I just grab these? And then G, yeah, like I want to move this whole thing, come on, over to like here. Right? And then we can move these over to, oh, no. Oh, that's what's going on. Okay. So I'm going to left drag these. So I should get just the text. We're going to, okay. I got it. No. The G. There we go. GG no re. All right. And then we'll move this back like that. There we go. Because these should actually be, we'll do the same thing, left drag to get in just those elements. Then we'll move there. That's what I wanted. Something like that. That's looking good. G-U-D, good. All right. So I did that. So, oh, I did that and I'm confused. Never mind. Because the data bus comes up to this buffer. So then we can just take this bus and go all the way up to here. And then I should be able to just copy these elements and do one of these. And then say, let's add a wire and then a label for a D0 and a D1. And we'll move this one up to here, move this one to here. And then we'll put our cursor, let's see, 1 to here and hit Z. Yeah, look at that. Oh, almost. There we go. There we go. And now that's part of the data bus. I like how that works out. Okie dokie. Let's take this, come over here, wire this to there. And then we'll come over here. So this is interesting. It has a 22 nanofarad capacitor for some reason. All right. It's going to be a long time before I just use the properties panel. It's just, you know what it is. Even though this doesn't require me to open a dialog, if I hit E, this shows up. Well, that's still about the same movement, since it doesn't always show up in the same place. I just got to get used to being able to go over there. Okay. So that's looking really good. Okay, so then I think we're going to have to now go and create a part. Or, you know what? Here's what I want to do instead. I want to focus on this mess of gates right here for a little bit. I think this will be a better or good use of time. What I'd like to do is get like these gates done, and then maybe we will, well, let's get these 3 gates done and then decide. I would like to get that chip, but I think what's going to make more sense is, I think it makes more sense to come back like kind of up in a circle. And then that way, this whole, yeah, maybe we, yeah, so I think I said this last time. So let's, yeah, so we'll do this whole section now. And then that way, and then let's see where we're at. Because I don't think this will take too long. So let's do an add 74LS32. And then the first one's going to go somewhere way up here. The next one, nope. Okay. Okay, so this one's going to go right here. And then I don't know where the other one goes. And then this one is down here, and this one is here. And then this part I'm just going to put down here for the moment, because it probably doesn't matter. But I don't know where the decoupling cap for that one is at, so we'll figure that out later. So let's delete this one, because that's the wrong one. Let's move these. So I wonder, can I select all 4 of these and change their reference to be U13? Yes, you can. Oh, that is so nice.
There was much rejoicing.
Yay. Yay. That is really nice. All right, so these are going to flip. Nope, other way. Y. Nope. Okay. All right. So I'm going to do Y, Y, Y. And then I want to move all of these up. Actually, you know what I'm going to do? I'm actually going to hide. No, okay. Here's what I'm going to do. Let's change all of these to LS32. And then I'm going to put this one inside of here, this one into here, and this one into here. And then these three will all get moved back up to here. And then let's move that into here, even though I don't know where that one's at yet. Okay, so we've got those three gates. And let's see now. One of these connects to, so U13, let's see, U13 pin 10 connects to the clock of the 174. So that's what this one was. All right. And then pin 11 connects to something really far away. For the moment, I'm going to do an Apple II style label. That's going to go to U14 1. Because we don't have that yet, so I don't want to bother drawing a line over there because it'll just be kind of in the way. Okay, and then let's see, pin 3 goes to a 4016, which we haven't drawn yet. So I'm just going to do the same thing for now, because then that way at least we have it labeled and we can find it later. All right. And that'll be U921. It goes to a couple other places, but that gets us close enough. So let's move this down here. Move this one up here. Let's see now. So where are we still? I just lost my place. Cursory glance, I don't see this other gate anywhere. So I'm just going to, for the moment, I'm going to put it into this area for misfit gates until we figure out what we do with it later. All right, so now let's focus on the input sides of these gates. So pin 9 connects to pin 1 strangely. All right. Well, tell you what, let's go ahead and get a 74 LS14 because I have a feeling we're going to need them. All right, I'm just going to do the same thing. And then let's go 5 and 6 because that's going to go to pin 12. And then that's going to go to something over here. Then I'm just going to put the other ones up here until I know what's going on with them. All right. So this is easier. Let's do that one first. Then 9 will connect to 1. I need my other cursor. I always forget. I always turn the full screen cursor off when I take screenshots and do video capture because I think it's more distracting. But it's harder to actually draw stuff with the smaller cursors. All right, and then this net connects to 13 because it goes 10 to 13. And then that's going to go to a chip up here, which I'm just going to do this for the moment. And that's going to be U4, 5. And I'll delete that after we get the chip up there drawn. Okay, so that's 9 and 10. 12, 13, so 12 has another connection coming off of it. And that's going to the direction of the 245. All right. Let's see now. That goes something like this. Yeah, that looks like what I want. And then what about its enable? Where does that go? Oh, that goes way up there. I'm not going to worry about that one at the moment. So we got 9, 10, 12, 13. Is there nothing else comes out of here? Pin 1, we got that. And then does pin 1 connect to anything else? Oh, it does connect to this NOT gate. I missed that. So we can definitely draw that in. All right, and then we'll see where that goes here in just a second. And then pin 1, we did that. That's the only place it goes. Then pin 2 is going to come up here to U4 pin 10. All right, I'm going to move these gates because I haven't seen them anywhere yet to the land of misfit gates. All right, so that's essentially 2 and 1 and 13 and 12 and then 10 and 9 and 8. Okay. So this output enable, okay, I'll get that when we draw that other chip. So then that's going to go to this other chip. And that goes to another gate. I'll worry about that one in a minute. And then this signal goes to a pull-up resistor and a select pin. So why is it over here? What I kind of think I want to do is take all of these up just a little bit. That looks a lot better. And then we'll see where that goes. All right, so that goes up to here. All right, 155. All right, and then let's do a 74 LS 155. What is a 155? That's a decoder. Nice. All right, and then we're gonna, yeah, none of these pins are in the right place. Of course they're not. Why would they be in the right place? Okay, we'll go create a copy of that. File, save, copy as -MC-10, MC-10, symbols, MC-10. Open up this one, save, and then we're going to end up moving this because that's usually in the way, and then we'll move these because those are in my way. And then let's go for the right order. I'm just going to move the, well, let's see. What do we want to do here? We got 1, 2, 3, 4, 5, 6, 7, 8. Yeah. What we're going to do is we're going to move this up, move these down, and then we're just going to do the pin renaming thing again. I think that's a trick that'll work just fine. So this will be 9. This will be 10. This will be 11. This will be 12. That will be 7. This is 6. 5 and 4. All right, and then over here we're going to get 2y0. And then we have 2Y1, 2Y2, 2Y3, whoops, 2Y3, and then we'll do a 1Y0 and a 1Y1, a 1Y2, and a 1Y3. All right, so then what do we do? What do they got going on here? So 1 and 15. That's weird how they're doing these. So 14 is going to end up over here. Ground is going to end up over here. Pin 1 will end up to here. And then 3 and 13 just kind of do that for the moment. I might make this symbol slightly larger just to, yeah, we're gonna move this one click over in each direction just so I get a little more room for these pins down there. I think that looks a lot better. Okay, put you back over here. 16, 3, 13, 1, 15, 8. I'm going to move these up because I think we've got room for them. 2, 14, and then 4, 5, 6, 7, 12, 11, 10, 9, 2, 2, 2, 2, 2, 1, 1, 1, Y, 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 0, 1, 2, 3, 0, 1, 2, 3. Okay. So this is, okay, I see what they're, this is the one, this is like the first enable. And then this is the second enable. This is, I guess, input B. And this is input A. So then we got 1C and 2C. What did I? Silly. 1C and then 2C. All right. Okay, that looks good. So let's insert that into our schematic with the A hotkey. 74 ms blah blah 10. And then we can do something like that. All right, and then right off the bat, I'm going to no connect these so that I don't get confused later. Okay. And then this one, okay, so we'll delete this. Actually, I'm just going to delete the whole thing because I'm just going to do this. Okay. And then same thing on this one. This was going to be pin 5, I believe. That goes to 13. All right, now we can delete that. That looks mucho bettero. Let's get a ground symbol. Oh, you know, we can also copy as a couple of decoupling capacitors. So let's go ahead and do that. We'll paste this up here. So this is U4. Yeah. Let's do U4. Let's change its name. Okay, and then let's see. Here's what I'm going to do on this. We're going to make this because looks like we're going to have plenty of room above it, and so we'll just do 2 caps like this. All right, and so that will be C29. Actually, I'll click on the cap. That way we can do C29, and it can be Okay, it'll be C28, and it will be 22 nanofarads with a little n maybe, and C29 with 22 nanofarads. Okay, so now let's see, 28 and 29. Those were both 22s. Wonder how I feel about that. Okay, so where do those signals go? Those signals go to address 14 and 15. So let's see. If we moved this whole thing over here, this looks like, does the address bus end up coming up this way for some other stuff? It does. So let's just extend the address bus up here. And we will do address 15, which looks like it is, I think it's this top one. And then address 14 is below it. All right. Hey, Squire, good to see you. Jack, you as well. 2 caps for twice the decoupling. Yeah. Yeah. It does make me wonder why they wouldn't have just done 100 nanofarads, unless those are film caps for some reason. But I don't know why you would use film caps on a digital chip. All right, so the enable signal, which is not an enable, but I'm calling it an enable because I don't know what else to call it, is just the E signal. Yeah, I think for now I am going to just do the E to pin 1 because I don't want to draw. I just don't feel like I'm going to like that. So we'll just do this for the moment. Decide on that later. And then where does this pin go? Who knows? Worry about that one later. Ground we can worry about right now. Super easy. Barely inconvenience. Okay, so the output of this NOT gate ends up here, which if I move this over and move this over, move this over, we can make this slightly cleaner. Yeah, I like that. Okay, and then the other output, enable, goes to the non-existent gate. All right, so somewhere up here, we're supposed to have U30. So let's go ahead and just do something like this for the moment. All right, so this we're going to call U30. E is phase 2. Nah, okay. Okay. Yeah, it's messing with me because I keep thinking it is enable, and it clearly is not. All right. So G is 1G is connected up here. All right. Don't like this that much, but it is what it is. Okay. And then let's see. So that connects to 1G. And it also connects to this output, but they drew it by going all the way down here and then over. Yep, I don't think I want that. Okay, that might not bother me as much anymore. It's not as clean as I would like that to be, but that might be the best we can do. Why did that happen? Yeah, I'm just gonna have to go there. All right, so U21 comes down and joins junctions here. Let me highlight this so we know we're looking at the same thing. Yep. And that connects to there. And then 2G, I can even draw this just a little bit out. Comes around and it connects to the 3 output. Okay. And then pin 2 is address 12. Really? That's disgusting. Like I literally just want to do this. I think we can do that and get away with it. I think. All right. I'm not drawing that line. Are you kidding me? This is already a gross mess to be as it is. All right. Still have to figure out what I want to do with that, but worry about that later. Okay. What's pin 15 supposed to be connected to? On U, that's still not the right name. So U4, I lost it. Pin 15, oh, it goes way far away. Okay. All right. I really don't like this section, but I'm going to try this. If I set up a net class and I do address bus and I make the color, oh, nice. Oh, there it is. The defined colors, blue. And then I say for anything that matches address. So for the longest time, I didn't understand this net class assignment window, and I still wish they would come up with a better way. It's a regex window, which is it's regex and a pattern match, which I didn't realize for a long time. And you have to remember that it wants it in the path for the signals. So since I only have a single sheet, everything is on the root. And if I want to match all the address lines, I can use A star, which should get the address lines. I wanted to see what I don't like about this is it may actually match. Oh, I know what I can do. And then I'm just going to do address A. And then we're going to name that bus. Okay. So I did that because now all of the address lines are blue, including the bus, which, okay, whatever. And then, for example, now what we could also do is, what did they do for the data? I think they made it green. We're going to make it green. So then if we add a data bus and then make it green, which it sort of already is green. We'll make it greener. And then we'll match anything that matches D and make it data bus. All right. Well, you know what? That's really good because now it's not readable. I'm going to leave it for the moment. Okay. But my hope is that way when you're looking at something like this up here, where you're like, oh, this A12 is like, what is that? Well, it's blue. So that means it belongs with the other lines that are blue. I don't know what the yellow line represents. Like it's connected to something called select, but I don't know what select is. And I thought this had a color key. Expansion port. But that's like the only yellow line. All right. Okay. Okay. Let's take a look at that so far. Oh, well, since we're doing color stuff, we'll go ahead and do this too. We can say 5 volt rail, and then we'll say ground. 5 volt rail will make red. Ground will make black. Actually, I'm going to make it gray just so that it's slightly not black. And then down here, although there's, yeah, because like the default net labels are black, so that way hopefully it'll be slightly different. And then we'll say 5 volt, and then here we'll say ground. Say OK. And so now our 5 volt lines are black and our ground, wait, what? Our 5 volt lines are red and our ground is black. Yeah, that looks neater. I don't know. I'm becoming more and more, I'm liking that idea more and more. Doing that. I should probably like save a default somewhere, save a template so I can use that in others. I guess just like in PCB, there is this import settings button, so you could import settings from a previous project. I only point that out because in both the schematic setup and the board setup, that button has been there since KiCad 6, and I still see people ask for that button, even though it already exists. Like, I wish there was a way to import from an existing project. It's like, yeah, you can do that already. It's super easy. Okay. All right, so I tell you what, let's go work on the video processor. What is this? Or that's the PD4016. Yeah, let's go do that because we got to create that from scratch, I think. I find it highly unlikely that there is one of these already in MC6847. Yeah. And if we just do a search for 6847, nope. All right, let's go create that symbol. That'll be fun. So symbol editor, I leave symbols to the symbol minded. And then we will do new, no library selected. All right, MC-10. All right, let's do new symbol. The name will be MC68. Select input to disable device selection. What? I can't read the. I cannot believe YouTube doesn't just delete that on everybody's. So to override internal peripherals. Interesting. Interesting. All right. Let's do a save. So that's almost in pin order. Okay, that's actually an easy one. Let's do pin name DA0, pin number 22, and we'll rotate it to be this way, except that is not the right, nope. Okay, let's try that again. Not invert it. We want pin name DA0, pin number 22. All right, and then I want to do that 12 times. All right, so that is 22, 23, 24, 25, 26. Ah, curses. All right. 26, and then it starts over. And so this will be DA5, pin 13. And then we just go to 12. 5, 6, 7, 8, 9, 10, 11, 12. Again, it's 22, 23, 24, 25, 26, 13, 14, 15, 16. No 17. Oh, I'll bet 17 is like power. Of course it is. That's not what I thought it was going to be, but sure, whatever. So this is 18, 19, what? 13 is DA5, right? So then 13, 14, 15, 16, 18, 19, 20. Oh, I'm confused. Something's not adding up here. Oh, 12 doesn't connect to anything. I'm still confused. Unless, yeah, so 22 is DA0, and then it goes 22, 23, 24, 25, 26. 22, 23, 24, 25, 26. And then it goes 13, 14, 15, 13, 14, 15, 16, 18, 16, 18, 19, 20. Did I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 12 doesn't have a pin number. That's why. That's why I'm getting confused. Yeah, okay. We can probably figure it out at some point. All right, that's why I got confused. Okay, so now I'm going to do a Y on that. And then let's add a new pin. That's going to be INV 32. And then I don't know what this is. A/S maybe? 34. And then we get into DD7. All right, so what I'm going to do now is I'm just going to do DD0, 3. I'm going to do all 7, even though these pin numbers are a little strange. I think this will be easier if we said, okay, let's make this one 40, and then 2, and then it's 8, 7, 6, 5, 4, 3, and again it's 0, 1, 2, 3, 4, 5, 6, 7. Yeah, maybe it seems more likely it's like a way to, some way to do bank swapping, and maybe it's like a way to access maybe a ROM on an external card or external thing. That wouldn't surprise me if it was something like that. So is the 680, is the 6847, is this like what is this? I should have looked this up. I should have looked for a data sheet anyway, because we're going to need it to make sure we get the pin assignments right. MC6847 data sheet. I just saw VDG and assumed it was a video display generator. Okay. Yeah, according to the data sheet, that's exactly what it is. All right. Yeah, so we can maybe use this. Is this got the... No, this is a block diagram of a TV game. Love a TV game. I was hoping for a pin table. Maybe there is one. This is actually kind of a nifty chip. All right. Let me just do a save page as. I'll do that. And then I want to open this one. So I've started using this new or newer PDF viewer called PDF Gear. It's from a company in Singapore, and right now it's free, but you can edit PDFs, and it's a lot light. It's a lot more light. It's a lot lighter weight than Acrobat, but it's got some stupid ChatGPT stuff in it, and that worries me. Like, I don't know what the implication of that is. Yeah, so what I want is I want a table that tells me if they're input or output. This kinda, I don't know what this is. Yeah, so data. So like, I didn't realize. So the DA zeros are actually outputs, I guess. Well, that's why I was hoping there would just be a table that has all their functions. Maybe there is a description. I guess it wouldn't really have to have like DA0, DA1. Yeah, okay. Well, so DA is the display address output lines. Page 15 maybe. Come on. Why? This looks promising. Yeah. I think that's what we want. Okay. Okay. That might work out. At the very least, what I know is we have to take these now, and we're going to do this. I'm going to go into Sublime, and we're going to do a Control H, and I want to change pin input line. I'm just doing extra line or extra words to make sure we only change the output that I want to change, and then we'll do pin output line, replace all. All right, and then we'll paste this back in.
Okay, so AS is, or is that 8, or is it, okay, so it's, oh, I see what's going on. So that's A, not AS, and it's an input. And then RFHS, so, and then DD, I'm assuming is the data bus. That's probably an input, yeah. Okay. The sample design is actually the Coco design? No way. Hey, Pete, good to see you, man. It's been a while. Haven't seen your name pop up. Oh, display data bus. Yeah, okay, that makes sense. All right. And then what's INV? Is that an interrupt? So that's an input. Okay. We'll come back and look at the other signals in a minute. Okay. So then we have what looks like MS maybe. And what we'll do is I'm going to make my best guess at what these are actually supposed to be. And then then I'll compare it to that block diagram in a minute. I'd rather just get them typed out and then fix them up. Let's do that. Okay. Pin name is FS37. I think this is a 38, and maybe it's HS. You know, I'm really glad we got the data sheet because I'm going to need those here all in a minute. Okay. Why? I can't. Maybe 20. I feel like I'm in a really bad eye exam. CHE. I'm just gonna let me think. I don't know what a good way to do the. Is that theta? I think that's a theta. Yeah, I'm going to do the inversion also in a minute. Let me get them typed out first, and then I'm gonna come back and fix this. It's just I don't want to switch back and forth, but I also want the pins to be in the correct order. So if we can at least get them in the order, it'll be easier to fix. Oh look, this display chip supports cascading style sheets. That's nice. Oh, did it again. I'll change that later. GM030. GM1 is 29. GM2 is 27. And internal, external is 31. And then I'll go ahead and add, so we don't forget them. We'll do VCC, pin 17, and make that a power input. And I'll come down here and VSS, and that'll be pin 1. And that's also a power input, which is a little counterintuitive, but that's the way that it is. All right. Okay, let me save that. Now we can go back to the block diagram. Okay, so pin 12. This doesn't have the pin numbers on it. Okay, tell you what. Let's go back to the top. Because then we can at least use this one to get the pin numbers and names right, and then we'll get the directions in a second, even though I know you guys probably know them. All right, so 12 is MS. And 37 is FS, and 38 is HS. Okay. And so we'll just do that. Nope, that's not even close. Okay. 33 is the clock. 20 is... Okay, Y is 28. Wait, it's phi? Wait, really? Aw. I swear, I thought those were thetas. It makes sense. I just fail. Thank you. All right, so 28 is Y. CHE is actually CHB. And then 11, 10. All right. And then let's see, 39. All right, 35. Whoops. Is AG. 30 is GM0. 29 is GM1. 27 is GM2. And 31 is whatever that is. Okay, and then 12, we already fixed 12, I think, right? Yeah. So I think I got all the inverts correct. So I think we've got at least that going for us. I'm going to zoom out one more time. And then VSS is 1. 17 is VCC. I just realized this is one of those symbols that mixes up source and collector, right? It should be VDD and VSS or VCC and VEE, but the symbol uses both. Although this is maybe this is a mixed signal chip. I don't know. I guess that could be a possibility. Okay, so now pin 31 is inverted. Did I get that yet? Yeah, I tried to do it. Oh, thanks. I see what I did. I missed the tilde. Okay. So now I'm going to go back to page 15 and just look at what all of these are. So what did I just say? So in the block diagram, it's VDD, even though in the schematic symbol, it's VCC. I have to laugh about that because that's one of those things that people try to like, aha, got you on videos and stuff. And it's like, even TI mixes up VSS and or VCC and VDD all the time. Like that's nobody gets it right anymore. All right. So CC, I'm trying not to have to zoom in too much. Nope, that's not the one I wanted. I wanted to do this because these are really the only ones I care about at the moment. All right, so CHB is an output, and then those are what do you call it? I was thinking these were clocks, but it looks like those are the is it chroma information? What am I missing? Wrong one. Let's try this one. TTL got us to know VCC and ground. Yeah, right. TTL. You know, I was looking at some like tube schematics not too long ago, and I wonder if in another 10 years or so are digital schematics like this going to be something that people have a hard time reading? You know, when are these going to become, when is digital schematics going to like not make sense? Like for me, when I look at like tube based or basically any schematic from the 1950s, I recognize the symbols and that's about it. All right, so GM0, GM1, GM2 all look like inputs. HS and R. Wait a minute. Where's the RF output? So this is an output. And okay. AS is an input. Internal, external, or I'm guessing interrupt. That's an input of some type. INV is an input. And then what was this? Oh, that's the address data thing. Okay. All right. So, oh, FS is an output. And then MS is an input. I feel like this RF signal is probably an important one. PB is the difference between blue and Luma. Oh, okay. Yeah. Internal, external. Oh, I see what you're saying. Okay. Okay. Yeah, internal, external makes more sense. Good point. Oh, is RF not used? Oh, is the RF not used on this chip because it has an RF modulator, so it's just taking the component signal and doing something with it? Which pin was it? So, is it pin 36, which is clearly labeled RP? I guess RF doesn't make sense. Maybe it's supposed to be RP, but I just think it's funny, right? So this says RP, and then down here it's RF, which I'm guessing is supposed to be RP because there's no RP on this block diagram. I'm going to go look at this other diagram really quick and see if we can figure out what it's supposed to be. This is RP. It's on pin 1. No. That's going into this chip. Never mind. And then in this description, I should have just read through these real quick. Okay, so it's RP. It's row preset for an external ROM character ROM. That's what I was trying to say. Okay. I don't think our symbol uses it. So what I'm going to do is let's go ahead and add it. But I'm going to make it invisible. And so let's do RP 36. I think it was an output. And then style will be, wait. Actually, I'm going to do it as just not visible. And then it's going to end up like in here somewhere. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What's 21? All right, this one is 21. Um, 22, 23, 24, 25, 26, 27, 28, 29, 30. Let's see, 31, 32, 33, 34, 35, Is there what's 35? AG? There it is. Oh, I gotta fix this one. All right, and then 36. Okay, 36, that's the mystery pin. 37, 38, 39, and 40. Okay. All right. Okay. Oh, wow. It's like raining, I think. But it's like really heavy rain. It sounds like rocks are falling on the ceiling. This has been such a weird winter. All right, so these can move back. And then let's move this one more. And then, okay, we're going to move this over one to make this centered a little better. And then I'm just going to move this up here for the moment. This can go here. This I'm going to try to put inside, but I'm sure it won't stay. There's motion in your backyard. Yeah, it sounds like a rock, like a landslide outside. Okay. So, if I look at that, now where is the center? It's, oh, so I'm going to cheat a little bit. Where's my center at? It's on DA1. Ah, come on. And then that's easy to find. So then we're just going to hit M. I'm going to hold the button, put that to there. And this should nicely center our symbol. And then I want to make the fill to be body background color. Yeah. All right. That looks good. Look at that. There we go. 60 degrees in Traverse City. Holy cow. Yeah, it was like it was easily 50 degrees in Chicago today. It was really funny too because I sent a message to a friend of mine and I was like, "You need to get outside. It's gorgeous outside today. Great day to go for a hike." And then she sent me a message 2 hours later and I was like, "What are you talking about?" And I looked outside and it was gray and cold, or getting colder. I'm like, how did that happen? It was sunny and warm at 10 a.m. All right. Okay. So I think we're good with this one now. Right? We've got, oh, I was going to move this so that's out of our way. And then we need to make that unconnected. And then we can move these all up a little bit. But I think we're good to... I'm going to move this down a little bit because we've got the room, and I just have this feeling it's going to be a cleaner layout. Okay, these might still end up moving some. Okay, let's give this a shot. Okay. Yeah, actually there's a house in my neighborhood. They've already planted new bushes and some new plants, and I'm really surprised by that because I feel like this might be just a little bit too early for it. It's a house that they recently bought and remodeled, and then I think they moved in probably about this time last year, And they did the same thing last year. They planted a bunch of stuff right before the last freeze. And yeah, I'm curious how it's going to work out for them. Okay. Let's go to our schematic and plop this down so we can say that it's, you know, down. All right, so now we have a video display generator. And now I got to do a whole bunch of signals. All right, well, okay. Oh, you know, let's do a couple of housekeeping items. I want to make this be U11. And then let's add our decoupling capacitors, which I always miss the ground somehow. All right. And then this time it's a 100 nano. Why don't they just use 100 nano all the time? Yeah, snow next week. Yikes. I did see the temperature was going to drop probably at night below freezing, but it's still going to be uncharacteristically warm, which only worries me because I don't know. I'd rather have a mild winter and a hotter summer just because I can deal with the heat better. Hello, Crowned. Okay, let's go C17 on this one. Curses. Gravity, you win again, Gravity. That's what is that? That's a Zap Brannigan phrase. You win again, Gravity. All right. Okay. Well, now you could have. Come on, man. I mean, I probably would have still laid it out just so that it matched this schematic, but yeah, it would have been nice to have. All right, so let's do a label VA0, and then we'll do the insert trick to get up to 11. Then I'll highlight and hit Y to rotate them, and then we're going to move those to be, I'm going to put them roughly here. And then I'm guessing, let's see how good I am. Z. Nope, I'm off. Z. There it is. All right. And then now I can just insert that a bunch of times. So we got that going. And then we're going to create a bus. And this is going to be a new bus. Nubis. And this was for, what is this? This was for the video or display address bus, right? So then I want to go and let's go create a slightly different blue for that. So we'll call this the display address bus VAX, and I'm going to select just a slightly different blue. I'm going to do VA question mark and say display address bus and VA question mark question mark. Oh, you know what I forgot was the slash and a slash. And we'll make that there, and we click OK. That'll be blue. Isn't that great? I like that. New bus. Yeah, that's exactly what I was thinking of when I said that. The good old days. Okay, so then we have this data bus, which I want it to get connected up. So let's do that next. Maybe we'll make this like another green. Probably really need to select something other than green. All right, so we'll do basically I'll do the same trick. I'm gonna do a label, VD0, and then get all 7 of those. And then I'll highlight and Y to flip them upside down, and I'm gonna hit X to flip them the other way, just because that's kind of how I like those to sit. That looks like that'll be a good spot there. And then I'm gonna draw my line to be about there. And now we'll do insert a bunch of times and see if I can get it this time. Z, but Y. No, but X. Oh, X. Oh, not even close. All right, so I'm just going to do Z 1, 2, 3, 4, 5, 6, and I'll highlight them, hit X. I'm going to move those over to here. And now we're going to copy this whole blob of stuff. I'm going to paste, but then I'm going to X to turn them the other way. All right, so now we can hit B to draw the bus and come up this way. All right. And I am thinking, let's go. So let's see. This bus did not get named. So I can name this 70. This one didn't get named either. So let's name that one 0. And that's named already. Okay, I did that because I want to do this. I want to add a pattern. So I'm just going to say VA 11.0. Oh, no. I remember now. I think you have to actually create a group bus to get highlighting to work. Or is it because it's regex and so it's confused what I'm trying to do? No. Yeah, I think what you actually have to do is this. I think you have to come in here and say, I want a bus alias, and I want it to be VA or VA 11.0, and I want that to match VA 11.0. And then in here, you can say, I want it to be VA 11.0. No. What if I say match this? Shoot. I gotta look this up. I can't remember how to make this, to accomplish this. Yeah, it's not getting my alias. And I can't remember how to do the alias. Okay, tell you what we're gonna do. We're gonna go, because I just remembered, my Game Gear schematic is in KiCad 7, so it's really easy to launch them both at the same time. I'm curious what I did on this one, because the control, see, like this control bus is a group bus and it's blue. And then this address bus is the right blue. So what did I do? All right. So I only have one address. And then in here, okay, so you do a slash. Yeah, that actually worked. Oh, no, it didn't work. Okay, you know what? I think I know what's going on. I think it is actually working. Let's try it. So first, let's delete this because that's not anything. I actually think I just want to do this and then say display address bus, even though this isn't matching correctly there. Yeah. There it is. That's not what I wanted. I wanted this one. Okay. So then like down here, so did I ever name? I did name the data bus. So if I come back in here and then say D0, oh, really? Did I do that? I'm going to rename it. And then say data bus. I'll click on the right thing. And then we're going to rename this. I'm just going to go the other way, just because everything else is going the other way at the moment. Oh, what the heck's D7.0? Yeah, that should have worked. Huh. It's not, is it named somewhere else? No. Okay. Oh, interesting. Interesting. So if I edit the label, wait. This might be a bug. Oh, so this should have been address bus. And so this is not the right blue. Like, I don't know, it's very obvious to me. That blue is lighter than this blue. And so if I edit this label name and change it to, and then the other thing I'm going to do is I'm going to copy this because I want to just paste it in. So changing it, the color doesn't change. If I come into here and click OK, it still doesn't change. If I move this off and then move it back, then it changes. So editing the label isn't working. Okay. So Cocos have a, do they really? Yeah, I haven't looked at the Coco schematic at all. So I don't know if I have one. I might. If I do, it's in a box somewhere. Okay. All right. And then I was doing all that because I was like, oh, you know what? I really like to do this video bus as well. So like we said, video data bus, and made that like a dark green. And the only reason I'm thinking dark green is because the default is a certain green color. I don't know. We might change all this later. So VD 7.0. I'm pretty sure if I just do this, that won't be enough for, well, wasn't enough for anything. What the? Oh. Yeah, so that's, so notice, so yeah, see, notice this. It did 7 and 0 because of the regex match. But if I do VD question mark and then make that video data bus, this is going to, what did I just do? I don't even know how that happened. VD question mark. Oh, I see what I did. That'll pick up the rest of them. Okay. So now those are all dark green. Or are they? That's a different green than that is. Wait a minute. Wait a minute. It didn't change all of these, even though this says they're matching. Did these up here change? So these are correct. What is going, okay, something's going on because, no. So these are the correct color, but these are not. I wonder if it's the same thing. Can I, what if I just grab all of the labels? I can't select them now. What? Bring them over here and then bring these back. Then it gets it. Interesting. Yeah, there's definitely something where the matching is not consistent. So that's weird. I think I'm going to write up the one that's really obvious with the address line, and I have a feeling it might be the same problem. No, you don't actually have to name, well, you have to name the bus at some point. The thing that's frustrating is, as far as ERC is concerned, the VD 7.0 or 0.7 is the same, but to match the net class for the color, it does actually matter. But as long as the bus and the labels in the bus match, when you run ERC, KiCad will connect them together. It'll see them. The reality is buses aren't really, they don't really do anything. They're entirely visual. Now that said, when you make a group bus, which is where I was headed towards, is you can actually create a bus. So like in this schematic, I have a bus. This is for the Game Gear, different design, but I created a bus called Control, and Control has all of the control signals, which are not, they're not numerical members. And so it's a slightly special case. So like if I come into bus alias and look at Control, these are the members of this aliased bus Control. I'm not sure how I feel about that, because I think that's really confusing. At least it allows you to create at least there's a way to have a bus with arbitrary signals in it. What I think is frustrating is I should just be able to do this. I should just be able to say, you know what? I want a bus called, or label Baldy, right? I should be able to create a bus like that. And then I should be able to create signals on it. Oh. And just have them be whatever I want. Like I should be able to do this, and then label go like blue and water or where and donut and phase 0. Right? Like, I feel like you should be able to do that. However, ERC will say, well, let's see, what can I do? I'm just going to add ERC is going to have a fit about this. Right? So in theory, these resistors should be connected to these resistors, right? If I try to highlight this, oh, but yeah. Yeah, okay. I want to see what ERC says now. Yeah. See, it doesn't think the nets are actually part of that bus, which is really frustrating. I'm only up version 8 with the bug reports. Hey. So I do think at one point there was an order in which you had to do the buses, but I don't think that's the case anymore. And I feel like that was something that was addressed. I want to say version 6, they made a big change to the way that buses are handled, and I didn't really get into them until version 7 when you could do color coding. That's kind of like where I got. So, okay, here's where I'm doing this totally off the cuff. I don't know if this is going to work, but we're getting the DRC warning that this signal is connected to the bus, but it's not a member, right? And that's really frustrating. However, if I come into bus alias and I create a bus called, nice, Baldy, and then we add blue, water, donut, and phase 0, in theory, those warnings should go away. They didn't. But I have a feeling I know why. Well, or did I not name it right? Nope. Okay. Yep. That was a failed demo. I thought that was going to do it. I really did. Huh. Hold on. Hold on. Oh. Oh, it's even worse than that. Oh my gosh. No wonder. Okay. There we go. See?
There was much rejoicing. Yay.
Yay. So, see, I think that's stupid. I think if you create the bus alias like this, then anything you connect to it should populate in that other table just automatically and be done with it. And then that way, at least it's like, okay, well, this is still a little counterintuitive how you name the bus, yeah, I can't think of another way at the moment because I kind of know why. I kind of think I know why they did this. Oh, wait a minute. Hold on. What is this? Hold on. If I click on label properties and I say net class is, oh, wait a second. If I click on this and say net class is, I'm going to just go 5-volt rail. Okay. It doesn't do anything at all. Oh, I thought that was actually going to do something. What does show do? Nope. Okay, well, that's interesting. What's show name do? Nothing. What's this do? Net class. Okay. I'm not sure what the point of this is. Anyway. All right, well, that's fun. Okay. We're going to stop there for now. Actually, there's what's this one complaining about? Different unit counts. I don't know what that means. I've never seen that one before. Huh. So this one, those are supposed to be 12. And then why did this one get a question mark after it? I think I did that. I think I screwed that up. All right. Then what is this error? Not annotated. Well, I just annotated it, so you're wrong. Oh, unit 4 is not annotated. Okay. Okay. All right. Yeah, there's actually, so regarding this whole bus thing, so part of why I even wanted to do it tonight was somebody on the KiCad forums, where they brought it up. They're like, well, why can't you just add arbitrary names? It's like, well, you can if you find in the documentation the explanation on how to do it. And then their complaint was, well, that's not intuitive. It shouldn't be that way. Why is it that way? Blah, blah, blah. And you know, that really bothers me because it's a combative. I don't understand. Okay, I'm going to say this, but then I'm going to backpedal after I say it. I don't understand why people take a combative attitude when KiCad doesn't do something they expect it to do. Especially when it's like, I'm looking for the rant thing. So, especially because first the attitude was, well, you can't do it this way. That's really dumb, blah, blah, blah. It's like, okay, well, you didn't ask the question, is there a way to do this? Which is the question that should have been asked. And then there wasn't okay, now I understand how to do it. There was a long list of combative, why is it like this questions. And that really bothers me because in a project of this scope, it's pretty common for something to get implemented as let's implement the functionality and then understand how people want to use it later. Right? And I think that's a perfectly normal thing. It's like, that's fine. Like this whole bus alias thing. Yeah, I don't like the UI either. However, it is still functional. And before it existed, I couldn't give any back or any feedback on how I would want it to work. Right? But like now that especially now that I've used it more than once, I have some thoughts on the way it could be implemented and the way it could work, but it just don't. Anyway, I just don't understand why people get like, especially around KiCad, why do people get so toxic about the way it does things when it's like, okay. And I'm trying to even avoid it's open source, so you can just fix it yourself, which is a stupid response. The additional trigger thing for me is when people bring this stuff up and somebody says, like in the specific case of KiCad, but this happens with lots of projects, please report this over here where we track it, and they never do. And it's like, just copy and paste your forum post. If you're just going to be lazy, just copy and paste it so that it's done. Okay, I'm off the soapbox. Sounds like a 5-year-old and they tell him no. I muted the thread and closed the window, and I've tried really hard not to open it back up because I want to respond, and I'm not going to. So pseudo attacks, yeah. I mean, I think, in fairness to the developers, they do kind of put up with a lot of. And I don't know what it is about KiCad, like specifically, but people seem to like just want to be, I don't know, contrarian. I can't think of combative is the only word that I can think of. And I don't know why. And the only thing I have to be careful about is I was kind of that way too, back in like the version 4 days when I was like, how can it even possibly work this way? And it's like, so I do sort of get it, but also, I don't know. I've just noticed it with KiCad especially. People just there's just like this expectation that it should work exactly how you think it should, with no understanding as to why. And actually, I'll backpedal that a little bit. When I used to get irritated with version 4. It was because every single time I said, why does it work this way? The response was, well, that's just the way we've always done it, right? And what I've noticed over the last, especially 2 years, you might get that response of, well, that's the way we implemented it. But then there's usually because of something, right? And I don't know. Okay, I'm done. Yeah, that's, I mean, a big part of it is, yeah, that's exactly a big part of it is that people don't want to change the way that they do things. And that's another aspect that that like just straight up irritates me. Like, I'll tell you, I have to turn the rant thing back on. The one that really gets me is when people bring up the way that symbols and footprints work in KiCad. And you can almost always tell, like, it's like somebody will start the post with, I'm new to KiCad from Eagle. And it's like, oh God, they're going to be mad that they typed in a part number and they couldn't find it, or that they have to connect the symbol and the footprint. And it's always like, it should be like Eagle. It should work like Eagle. And it's like, you know what? It really should not. I'm not even saying that KiCad's implementation is better, but functionally, I think it's better. You have symbols, you have footprints. Maybe there needs to be another layer that connects things together, but the symbol library should not have 20 versions of every component just because there's different packages for it. Like, that just makes no sense. So, and then on top of that, you can create a library to do it. Like, just make your own library. Just create one. And then that way you have exactly what you want. You know, and I saw this complaint just recently, and that's why I'm triggered about it, because it was like, well, I shouldn't have to do this. It's like, well, yeah, actually, I think you should, because now you're saying, and especially if in the case of, because like, okay, let me just show this, because this is, to me, this actually matters. Like, here's what I do, right? I create, and I need to overhaul this at some point. I just haven't gotten around to it. But I created my library. How do you find it? So I created something called My Library that has a whole bunch of stuff in it that only I use. But one of the things I did is I created things like D1206 and C0805. And the reason I did that is because I wanted a capacitor symbol that had a specific footprint. And like, okay, I'm done. It's like, there. Now I have what used to be an Eagle, except it's exactly what I need and only what I need. It's also built on the symbols that are from the library. So if somebody says, hey, you know what, turns out our footprints for capacitors were wrong, I don't have to do anything. It's fine. So I don't get it. I think the reason people get mad about the way that KiCad does it is because they're used to the Eagle format or the Eagle method, and in their mind, all they can think is, well, KiCad must suck because it doesn't do it this way. And it just irritates me that when you're getting to know a new piece of software, you can be frustrated that you're having trouble using it. But you need to keep an open mind that you don't understand how it works. And that's not to say it's correct the way that it works, but you should at least keep your mind open long enough for you to understand why or how something works before you immediately say this is the wrong way to do it. Again, maybe it is the wrong way, but maybe there's also a 10-year legacy reason that it's there, and it isn't as bad as people, like the alternative way isn't better. That's what I was trying to say. So, okay. Okay. Anyway, by the way, I'm working on an add-ons video. The title is I was going to show these off, but I think I'm just going to show this real quick while I'm waiting for this other stuff to finish. I meant to originally I was going to open this up and close the stream with, oh yeah, save those changes. I'll just do continued work. Why not? I was like, oh, wait a minute. Let's try that again. Yeah, the downside of using Dropbox and Git at the same time is they sometimes get mad. So here's what I'm doing. I'm doing the 8 things I like about KiCad 8. So the properties panel is not only is it in the schematic editor, but it's also in the symbol and footprint editor now, which it wasn't in the footprint editor in 7. The grid overrides, I talked about that earlier. That's where in schematic, now when you move wires and symbols, they're locked to a 50 mil grid, regardless of what your regardless of what your setting, but regardless of what your grid setting is. I did want to add something real quick. Also, when pressing grid hotkey, a pop-up shows up to show the grid is changing. So that's like really nice. That's going to fix a lot of the off-grid problems. Alt pin assignments, I don't have a good reason to show that yet. Or I don't know, the crystal. Instead of having those 3 names in the pin name, you create alternate pins, or alternate pin functions, which has been around for forever, but it was a pain in the butt to change them. Now you just right click on the pin and select the one that you want. You can have editable power symbols. So like if you want 5 volts A or 5 volts and 5 volt standby, you just have to edit a 5 volt symbol and change the name, and now you have a new power symbol. In the past, you had to create power symbols, which was a pain. There's a new bill of material generator, which I haven't gotten into at all yet. In PCB, you can take a custom polygon, right click, and turn it into a net. So like if you have like a funky pattern for like a pad or something, it's any polygon can be a net. If you click multiple parts, you can drag them at the same time with limitations, and then a bunch of other stuff. So anyway, I was gonna like actually go through more of those, but I'm tired. So okay, that was fun. Blender, yeah, Blender's a whole nother. I actually kind of want to go look at the Blender forums and see how that community reacts, because Blender is a hot mess, and it's one of those things where I see people complain about the way it does things all the time, and it's like, well, you're in the wrong workspace, and there's a reason it works this way in that workspace. But yeah, so all right, thanks for hanging out, guys. Haven't had a new or it'll be a while before there's a new Workbench Wednesdays. In fact, I just finished it the other day. I'm really excited about that one. It's how do you pick the pull-up resistor values for I2C, and why some work and why some don't. Turns out, like everybody says, measure or estimate your bus capacitance, but nobody tells you how. It's like, okay. And then yeah, and then hopefully, I'm hoping over the weekend to finish this KiCad 8, but I don't want to release it until they release 8, so I might have to come up with another add-ons video in the meantime. So, all right, thanks for hanging out. Good to see everybody. Hope you find time to work on something fun and something you enjoy. And if you do, please make sure you share it with people. So, take care. Catch you later. See you next week. Bye.